So there's this rule, the limit of the arctangent of x divided by x as x approaches 0 equals 1. And I want to prove it, so like, yeah. Okay, so the idea is that there's a rectangle. I'll call it a blade, and it has a width of w and a length of r for like radius. And there's another blade touching the alternate opposite corner, so it's like going across it. And it's identical to the first one. Now usually going for those two corners would be longer because like Pythagorean theorem and stuff, but like it's as the width approaches 0, so it's the same length as the radius. Now there's an angle that I'm gonna call theta because it's a cool symbol, and if you take the arctangent of w divided by r because like the opposite over adjacent, and still take into account that w is approaching 0, and then like you imagine a bunch of these blades in a circle, like those fans that open and close. The thinner the blades are, the closer you get to the real area of the circle, kind of kind of like integration. And yeah, that's like another reason why w has to approach 0. That's why the limit's there. Anyway, so I need to fill up half a circle with these blades, and I need half a circle because, like, one blade is covering up half of another blade, so really half a circle is the area of a full circle, as, like, w approaches 0, obviously. And to find how many blades you need to fill a half, you need to divide the angle for half a circle, which is pi, obviously, by what I just stated, which is the limit as w approaches 0 of the inverse tangent or arctangent of the width divided by the radius. And you need to multiply that by the area of each blade. Because the number of blades multiplied by the area of each blade, okay. Then you get the formula that you see on screen, okay, because I don't want to read it out. And pi r squared is like the formula for area of a circle, so you set that equal. Then you do a bunch of other stuff. Then you find that 1 is equal to the limit as w approaches 0 of w divided by arctangent of w divided by r times r. Yeah, okay, I'm not gonna read formulas from now on. But for simplicity's sake, we're gonna let r equal 1 because r can be any value and all that. Because like it's a circle and it's the same. So anyway, so then you get w divided by the arctangent of w. Obviously the limit is still there, I don't want to read it. And boom, proven. Yeah, I guess. I'm not even sure if that's how you prove stuff because I haven't learned proofs yet, but yeah. Oh yeah, another cool thing is that the radius can be any value, which is kind of cool. So like as w approaches 0, then the inverse tangent just doesn't exist anymore. I don't know why, but you can just take it out and you can cancel out the r's. Like yeah, it's super cool.